So, uh, today we are going to discuss about dielectric. Okay, so the first question is what is dielectric, right? What is dielectric? So we know there are different type of materials, right? Some of them are known as conductors, and some of them are known as insulators. Now, what is a conductor? Conductor is a metal, or it's some material where there are free electrons, or we can say there are charge carriers, or we can say free charge. So what is a dielectric? Dielectric is a material where there is no free charges. No free charges. So if there is no free charges on a material, then that material is known as dielectric. Okay. So in case of dielectrics, what we can have, a dielectric material can we have monoatomic dielectric material, or it can be have molecules, right? It can have molecules, different molecules. So in case of monoatomic dielectrics, what will happen? There is like it's only one atoms, like only one type of material. So if it is only one type of materials, maybe it can be a plastic. Plastic is not obviously monoatomic, but we can say if some material is monoatomic, that means this is elementary material. In that case, what will happen? There are only atoms. If this is a materials, and there are only atoms of that material, right? And inside atom, what happens, right? We know inside atom at the center there will be positive charges, and around them there will be negative charges. And आमे जानिछे कि सेंटर जो पॉजिटिव चार्ज थाए और अराउंड जो इलेक्ट्रॉन्स बुलुछन्ते, राइट? इलेक्ट्रॉन्स जो जेमती बुलुछन्ते से इलेक्ट्रॉन्स मनकर जदि आमे सेंटर नेवा तो सेंटर कोडा एटा. ओके, सेंटर होछि न्यूक्लियस. अगेन द पॉजिटिव चार्ज ऑफ सेंटर न्यूक्लियस. और आमे जानिछे कि आमे बाहर कोथि तो ऑब्जर्व करिवा ताले हम कोन लागियो कि पॉजिटिव चार्ज आर concentrated on the center, whereas same electric amount that negative charges are also concentrated on the center. So हमको लगेगा total charge 0. Okay, तो हमको फील होगा कि total charge 0 अच्छी, because हमें जानिछे कि जो चार्ज टा यूनिफॉर्मली डिस्ट्रीब्यूट होता है ताको हमें एज्यूम करि परिबा कि से सेंटर ऑफ द समस्ते. So in this case what happening? In this case the center of positive charge and negative charge are aligned, or there is only single center, or also you can say these two centers are the two centers are coinciding. Okay, now there is another type of dielectric which we can say it made up of molecules, like it can be plastic, it can be water, it can be anything. Okay, so in this type of materials that we can see two type of molecules. One is polar molecules, and another one is non-polar molecules. So what is the meaning of polar molecules? If in the molecule it's like H2O, it's water, you will see that one side of this molecule will be a slightly positive charge, another side will be slightly negative charge. That means by default their center of positive charge and the center of negative charge are separated by a very small distance. Okay, so this type of molecules we can say they behave like a dipole, electric dipole. So in this type of material, that means in this type of dielectrics we will have dipole of each molecules. That's why this materials is known as polar molecules. These molecules are known as polar molecules, where these molecules have some dipole moment. Whereas in case of non-polar molecules, what will happen? The molecules, the positive charge of the molecules and the negative charge of the molecules, both of their centers coincide with each other. That means there is no dipole. It means there is no dipole in this case. Okay, so now we have understood, right? Dielectric can be of three types. One is monoatomic, and in case of monoatomic dielectric, we'll have atoms, and since atoms are there, so we can say the center of the negative charge and the center of the positive charge coincide with each other. Hence, there is no polarity of that atoms of that material. Now, again, dielectric can be of material can be of different molecules. So molecules can be of two types. One is polar molecule, and another one is non-polar molecules, right? So in polar molecule, what happens? In polar molecules, you will see that the center of the positive charge and the center of the negative charge are separated by a small distance. That's why you can see they will behave like a small dipole, and hence these molecules are known as polar molecules. Whereas in case of non-polar molecules, what happens? There is no the center of the positive charge and the negative charge coincide with each other. Hence, there is no dipole moment. So they behave like a neutral molecule. Okay. Now, even in the case of polar molecules, the dielectric is made up of polar molecules. For that case, also what happens? Because of the thermal agitation, that means because of the temperature, they have some random motion. The molecules have some random motion, right? And they will arrange themselves in the random way. That means, suppose let's say this is the polar molecules, and they will arrange like this. I'm just drawing like this. This is positive, this is negative, this is one molecule. So because of the thermal agitation, what will happen? The molecules will arrange in random direction. Okay, in the random direction. So dipole moment will be in the random direction, right? And hence, in total, when you will see, the total dipole moment of this material will be how much? Moment will be 0, because they will arrange in random direction, and finally they will arrange in such a way that the total dipole moment will be 0. That means the whole material will behave like it's a neutral object. Okay. So we can see that in normal, if there is a dielectric, we will not see any dipole moment effect or anything, even if it is a monoatomic, or even if it is molecules, even if it is polar molecules or non-polar molecules, we will not see any difference. Now, what will happen when we will insert this type of material? When we will insert this type of material inside the electric field. So let's say there is an electric field. So let me draw it like this. So let's see electric field. Maybe it is a uniform electric field. So here it is a positive charges, and this is negative charges, right? Because we know electric field is directed from positive to negative. Now, what will happen when I insert this material inside this electric field? So if I insert this material inside this electric field, what will happen? Since the molecules are free to rotate, right? They can orient themselves. So what will happen? Because of this electric field, the negative charges of the materials, the negative charges of this pole will try to align in this direction, and the positive try to align in this direction. So we'll see that all the dipole moment will try to arrange in this direction. It will be like this. Obviously, there will be some molecules which will be oriented in the random direction, but most of them will arrange in this direction. You can see, right? Because of the electric field. And why there are some molecules which are arranged in the random direction is because of the thermal agitation. Because of the thermal motion, they have some energy, so that they can arrange in their way. So if we just increase the electric field intensity, then all the molecules will arrange themselves in this way. Okay. And one more important point: we know for a dipole moment, for a dipole, if it is a dipole, the direction of the dipole moment is how much? The direction of the dipole moment is from negative to positive, right? From negative to positive. This is the direction of the dipole moment. Okay. So basically, what is happening? It's happening that all the dipoles are trying to align in the direction of the electric field. Okay, so this is the point. So if this is a polar molecule, this will happen. Now what will happen if I insert a dielectric which doesn't have any polar molecule? If that is a monoatomic, or if it is a molecule without any polar atoms, what will happen? In that case, this is the molecule, right? And we knew that the center of the positive charge and the center of the negative charges were coinciding that time. But now what will happen? Let's say, so let me draw it in a single form. Let's say this is atom, this is the center, and this was the orbit of the electrons, let's say. So what will happen if I just apply some electric field? Let me draw some electric field. Let's say this is the electric field. So what will happen here? Because of the electric fields, that means there is a positive charge, there is a negative charge. Some of the electrons will get attracted towards this. That means the orbit will not be like this. After applying the electric field, orbit will look like this. See, this orbit will shift towards, because these are the orbit of electrons, right? So it will be something like this. So what's happening? That means the center of the negative charge and the center of the positive charge are slightly shifted from each other. So now it will behave like a dipole. Okay, now it will behave like a dipole. And why is shifted? Because of the electric field. Because of the electric field, the negative charge is going towards this positive, and this positive is going towards this negative. And they are experiencing force. That's why the center of the negative charge and the positive charge are separated by small distance. So this will behave like a dipole. And the same thing will happen even if for the case of non-polar molecule. Okay. Now whatever you saw here, this process is known as polarization. This process is known as polarization. Polarization means because of the electric field, the material is getting polarized. Polarized means what? The center of the negative charge and the center of the positive charge is getting separated. So the material is getting polarized. Now in the next video, we'll see some mathematical terms, how the material is getting polarized, with what amount, and how it is affecting the electric field and everything else. So see the next video and you will know everything about that. Thank you.